Okay, let's pull back the curtain on the world around us. You know, every time your phone unlocks with just a glance, or an AI creates some breathtaking piece of art, it feels like magic, right? But the truth is, what's really going on under the hood is something way more elegant and maybe even more amazing. It's mathematics.
So, over the next few minutes, we're going to explore this idea that math isn't just some dusty subject for engineers. No, it's the very foundation of innovation. Think of it like a silent, invisible engine, and it's powering literally all of the most mind-blowing breakthroughs we see today. All right, let's start with a little game. I'm about to show you four completely different, amazing pieces of modern tech. And as you see them, just ask yourself one simple question. What do all of these things have in common? What's the one thread that ties them all together? First up, the phone that's probably in your pocket right now. Face ID. That whole process relies on some pretty slick geometry to map out all the tiny distances between your eyes, your nose, your mouth. Then it uses these lightning-fast algorithms, which are really just step-by-step math recipes to confirm it's you. And it does all that in the blink of an eye. Okay, next, a rocket landing itself on a tiny little platform floating in the middle of the ocean. I mean, that's just wild, right? Well, that feat requires a whole symphony of calculus to perfectly predict its trajectory. And it uses something called control theory, which is basically the math of keeping things stable, to make thousands of tiny, precise adjustments against wind, against gravity, every single second. And what about creating new medicines? This is a huge one. AI systems like AlphaFolds are now using these super sophisticated statistical and geometric models to figure out the 3D shape of proteins. I mean, this was a problem that had scientists totally stumped for decades, and now math is helping to solve it. And last but not least, those AI chatbots that are everywhere now, the ones that feel so weirdly human, their ability to just understand you and talk back. That whole thing is built on a massive, and I mean massive, foundation of linear algebra. It's processing the relationships between billions of words on a scale that's honestly hard to even wrap your head around. So, did you figure it out? The common thread connecting all of it? Yep, it's all math. So, the big question is, how on earth does math pull all this off? Well, its secret sauce, its superpower, is this concept called abstraction. It's this incredible ability to look at a messy, chaotic, real-world problem and boil it down, translating it into a clean, simple, and predictable mathematical model. It's kind of like turning messy reality into clean, elegant code. And this process, it really does take chaos and turn it into clarity. So here's how it works. You start with something incredibly complex, right? Like a fast-spreading epidemic. Then mathematicians come in and build a model. They use tools like differential equations, which is really just the math of how things change over time, to describe how the infection spreads. And just like that, you get a powerful tool for prediction. We can simulate different outcomes, guide policy, and make smarter decisions that literally save lives. Okay, so now let's take that core idea of abstraction and see how it fuels maybe the biggest tech story of our lifetime, artificial intelligence. Because this right here is where the raw power of math is truly on full display. Right at the absolute heart of AI, you'll find linear algebra. And look, let's just forget the dry textbook definition for a second. The best way to think about it is as the assembly line of AI. It is the fundamental machinery that lets a neural network crank through billions, even trillions of calculations all at once, making sense of these vast oceans of data, whether it's words, images, or sounds. Now, you might see a formula like this one. This is actually from the paper that kicked off the whole modern AI revolution, and your eyes might just glaze over. It looks impossibly complicated, right? But here's the thing, it's really just a recipe. It's written in the language of linear algebra, and all it does is tell the AI which words in a sentence it should pay the most attention to, to understand the real meaning. That's it. Underneath all that complexity, it's just a set of mathematical instructions. But wait, how does an AI actually learn anything to begin with? Well, that's where optimization comes into play. So if linear algebra is the assembly line, you can think of optimization as the super strict quality control manager. Its entire job is to teach the machine how to get better and better by constantly trying to find the best possible answer and, crucially, minimizing its mistakes along the way. This is a really cool way to picture it. Imagine a huge, sprawling landscape with lots of hills and valleys.
Every single point on that landscape represents a possible answer to a problem. The perfect answer? Well, that's sitting right at the bottom of the deepest valley. The AI gets dropped somewhere on a random hill. It then uses this brilliant method called gradient descent. It just looks around, finds the steepest downhill path, and takes one step. Then it does it again, and again, and again, until it can't go any lower. It has found the best, most optimized answer.
Okay, so let's zoom out for a second. Because these core principles we're seeing in AI, this whole process of modeling reality and then optimizing for the best result, it's not just an AI thing. Not at all. It's actually part of a grand, unifying pattern that you see pop up over and over and over again across all fields of technology.
It turns out that most major breakthroughs are powered by just a handful of these core mathematical ideas. You've got symmetry, which is all about finding elegant patterns in super complex systems, like in physics. There's optimization, which we just talked about. That's the tool for turning any goal into reality. Then there's uncertainty, which uses probability so we can make smart decisions even when we don't have all the data, like in finance or weather prediction. And finally, structure, which uses things like graphs and geometry to attain insane complexity, and everything from social networks to biology.
Okay, so what does this all mean for you? Why does any of this matter? Well, the big takeaway here is really about understanding the fundamental fabric of the modern world that we're all building and living in. If there's one thing you remember from all of this, let it be this. You've probably heard that famous saying, software is eating the world. And that's true, but it's only half the picture. Because behind every single line of code, behind every algorithm, every microchip, there is a deep mathematical principle that makes the whole thing work. You see, technology runs on code, but the code itself runs on math. And that really leaves us with a final, pretty awe-inspiring question. People say that math is the language of the universe, and right now, we are getting more and more fluent in that language every single day. So as our understanding deepens, you have to wonder, what currently unimaginable breakthroughs are just waiting for us right over the horizon? What new frontiers are we all about to unlock?